Hello everyone, I am Snigdha Kakkad and this is my channel Accelerate AI Careers. Today I have brought a very interesting LeetCode problem, LeetCode 145, binary tree post-order traversal. This is a very important and interesting question, especially for FAANG interviews. It has been asked by so many companies in the last few months. So for example, Meta, Google, Amazon, Bloomberg, Microsoft, Apple have asked this question in their interviews in last 0 to 3 months. Now, why does this question has so much significance and what is the complexity level of this question? What does this question say? So even though the question has been marked as easy level complexity here, that's because if you try to solve it recursively, it's a very easy and very straightforward code. But if you try to implement it iteratively, the approach which I'm going to show here, it's a very complex question. I would rate its complexity to medium level complexity at least for post-order traversal. It's tougher than pre-order and in-order traversal. So let's see how do we implement it here. Now you have been given the root of a binary tree and you have to return the post-order traversal of its nodes values. Now what does post-order traversal mean? So in post-order traversal, basically, if you are given a root here, this tree, like in example 1, you essentially first find the leftmost child. So the leftmost child here is 3. So first of all, in your output, 3 would go. Then you find the corresponding rightmost child. So the child corresponding to 3 is null. There is no right child for 2. So that's why after that you jump to the root of 3 and the corresponding right child, which is 2. So 3, then 2, and then you move up towards left side, and then you go towards right side, and then to the root, and so on. So that's why in your example 1, you had this tree and your output was 3, 2, 1. Remember that the base node, which is 1 here, will come at the very end, and prior to it the right node will come, prior to it the left node will come, and so on. In example 2, you have been given this root, this as shown here. So how will you find the output for this? For post order traversal, you will first go and find the leftmost node. So for 1, left is 2, right is 3. For 2, left is 4 and right is 5. And for 4, the left node is null, like left child node is null. So your leftmost node is 4 here. So your output will start with this 4. Now corresponding right child of 4 is 5. But 5 doesn't have null child nodes, it has child nodes 6 and 7. So 6 is its left child node, so after 4, 6 would come. Then corresponding right child node will come, which is 7. Then you move on the top, you have the parent node as 5. So 4, 6, 7, 5. Then you have parent node for 4 and 5 as 2. So 4, 6, 7, 5, 2. Then you move up, but you cannot put 1 there. 1 comes in the very end. You move towards the right side. In the right side, you again go to the bottom and your bottommost left node is 9. Then you check for the right node corresponding to 9, which is null. So you move to the parent node for 9 and null, which is 8. And then you move up, which is 3. And then you move up, finally you get 1. So for getting post-order traversal done, usually if you implement recursively, recursion basically in the backend uses call stack. We are going to emulate the functioning of that call stack using a stack itself. And we are going to store the values in that stack such a way that whenever we pop the last value, that is the value which we need for post-order traversal. So to do that, we will not put the values directly in this order, like 1 first, then 2, then 3, then 4, 5, 6. If we do that, then we'll not be getting that value which we want to be popped in the stack. So we want to emulate this recursion function using the stack here, and that I will explain using an example. Suppose you have been given this root as shown here in the example, which has 5 and then left child 1, right child 4, and then left child 2 and right child 3. So as recursion would do it same way, we are going to emulate it using a stack here as shown here. So how should I put the values in the stack such that when I pop the value, that is the value which I can add to my results array. So let me show it to you here. So first of all, I will put 5. After that, I will go ahead and I will put the right child rather than the left child. So you have to pop the leftmost child first, right? So that should come in the end in your stack. And you have to pop the parent node in the very end, so it should come first. So I added 5 first, then I'll first move towards its right child. So right child for 5 is 4. So I will put 4 here. And then I will go towards the right side more. And 4 has 2 children, 2 and 3. Now left child comes first and right child comes next, right? When you pop it up, right? So you will first add the right child again 3, then you add the left child 2, and in the end you will add the left child, which is 1. So now if you have to pop it up from this and you use the normal stack pop function, so first 1 will get popped, after that 2 will get popped, after that 3 will get popped, then 4 will get popped, and then finally 5 will get popped. And that's your post order traversal. That's the output you want. So what are the 3 logics behind this entire process which I just showed you? First thing, we are going to use stack. Second thing, add that thing first, which you have to pop last. So you have to pop last the parent node, which is 5, right? So you add it first. Every time you add the parent node first. Then you add the right node, because you have to pop it second last to the parent node. And then you add the left node, because left node is to be popped before right and parent node. So that's the process I'm following. And every time you come across a node which has not null children, so you add those children first before going to the left node. So these are the 2 logics which you have to remember. And I'm not adding each node visited and popped every time to the result. I'm adding them only when they have been visited twice. So if you see, I first added 5, then I went to its left side and right side, right? So I first added 4, then went to its left side and right side, added 3, and then 2, and then 1, right? But when I'm popping them, every time I'm not adding them to the result as is. I will first check if they have been visited before. If they have been visited, then I add them to the result. Because if they have not been visited before and I add them to the result directly, then what I will end up doing is I will first add the parent node before adding the left node, which is not the answer. So you have to keep 3 things in mind. You use stack, you add those values to the stack first, which you have to pop last. So the order should be the parent node first, then the right child, then its subsequent children, in the order of right first and left last, and then the left node. So that should be your order. And you also keep track of visit using a visit array or visited array, which you use to check if that particular point has been visited before. And if it has been visited, then you add it to the result. So let's start coding it. I will first initialize my stack, and I will put my root value in the stack first, and then I will also initialize my visit array, and I will initialize my visit array with false, because initially nothing has been visited. Okay, and then also I will initialize my result array. So these are the 3 initializations I'm going to do. After that, I will start my while loop, while stack, and then I would get 2 pointers, current and b. B would be like if it has been visited or not. So current value I'll get by popping from stack.pop, I get the current value, and b I'll get by popping from visit array, so visit.pop. So these 2 values I'm going to pop like this. Then I will check if my current value is not null. I will check if it has already been visited. So you have to check if it has been visited, then you add it to the result. So result.pend current.value. Else, say suppose it has not been visited before. In such a scenario, if it has not been visited before, I will first append this value to the stack, because this value has not been added to the stack earlier. So I will add it to the stack. I will also add it to the visit array. So visit array, I will add the value true, that it has been finally visited. Then I will also append the child values of this node to stack. So current.write child first, as I discussed in the algorithm explanation, and then I will append false value for the child node, because I have not visited it yet. I've just visited the parent node and I'm adding its children nodes. And then finally I will also add my left child node. And finally, I also appended false to the visit array for left node as well, because the left child node has also not been visited, and I return my result. So that's my entire code. Let's run it. It's accepted. Let's submit. So as you can see, our solution is beating 100% solutions here available on LeetCode. So that's a big achievement. Now let me repeat the solution for you so that you understand it better. I initialized my stack with a root value, then my visit array with false since nothing has been visited yet, and I initialized my empty result. Then I looped through the stack, got the current pointer value by popping from the stack and visit pointer value, whether it has been visited, true or false. I checked if current value exists, it was in the stack, then I check if it was visited or not. If it was visited, I append it to the result. If it was not visited, I will add the values in the order. First, I add the parent node, then I add the right node, and then I add the left node, and finally I return my result. And every time I'm adding the value to the stack, I'm also updating its visit status to the visit array. So that's the entire code, entire crux of the question. If you have any doubts, ask them in the comments. If you like my way of solving questions, subscribe to my channel to get notifications for your daily LeetCode challenge. Thank you.